Before we talk about any shortcuts, let's start with the standard way to think about square roots. The square root of a number is simply the value that, when multiplied by itself, gives the original number. For example, the square root of 1600 is 40, because 40 times 40 equals 1600. The same idea works for much larger numbers. Even if the number looks complicated, the definition never changes. In general, finding square roots means searching for that number whose square matches the original value. Most people think math is rigid. But every once in a while, the numbers seem to glitch. Look at 81. Its square root is 9. And 8 plus 1. Also 9. Coincidence? Maybe. But then you see 2025. The square root is 45. And if you split it down the middle, 20 plus 25 is 45. Try one more, 3025, the square root is 55. And if you split it down the middle, 30 plus 25 is 55. Again. How about 9801? Its square root is 99, again, then, split the number down the middle, 98 plus 01 is 99. Unbelievable. These aren't accidents. These are lucky roots. And they go far deeper than you might expect or you may think. If you scale all the way up, from 6 digits to 8, 10, 12 digits, and beyond. And the pattern keeps appearing, even for massive numbers. Here you are watching the cases for 6, 8, 10, 12 digits. The secret lies in the underlying mathematics. In the 4-digit case, the critical value is 99. Define a 4-digit number ABCD. You are splitting it into two parts, x equals AB, and y equals CD. Mathematically, the number itself is represented as 100 times x plus y. Let S be the split sum of the parts, x plus y. Then, the square root of this number equals S. This special rule holds if and only if the split sum of the two parts must satisfy a precise algebraic condition. Multiply the split sum S by S minus 1, and the result must be divisible by 99. We'll uncover the details behind this shortly. And here's the real kicker. One of the most famous numbers here, 998,001, is actually a counting machine. When you divide 1 million by this number, you get a mathematically beautiful decimal, a kind of magic fraction. It literally counts upward in 3-digit blocks. 01, 002, 003, 004, forever. And here's why. 998,001 is the square of 999. The series expansion of 1 over the square of 1 minus x, for the absolute value of x is less than 1, generates the natural numbers. 1 plus 2 times x, plus 3 times x to 2, plus 4 times x to 3. And so on. When we set x equals 1 over 1000, that sequence unfolds, one number every 3 digits as you are watching. Math isn't just about calculations, it's about finding the symmetry hidden in plain sight. If you found this beautiful, hit subscribe for more mathematical mysteries. So, why does this work? To a mathematician, a 4-digit number isn't just 4 digits. It's 2 separate blocks. Let's call the first half, x, and the second half, y. For 4 digits, the number is actually 100x plus y. We are looking for cases where that number equals the square of x plus y. The most famous version of this trick uses strings of 9s. Why? Because these numbers are always the square of 10 to the power of n minus 1. For 4 digits, the square of 10 to 2 minus 1 is equal to 99 squared equals 9801. For 6 digits, the square of 10 to 3 minus 1 is equal to 999 squared equals 998,001. The logic, when you square a number like 999, you are essentially multiplying 1000 minus 1 times 1000 minus 1. This creates a predictable pattern of 9s, 8s, 0s, and a 1 at the end, which is why the split always adds up to that root of all 9s. But what about the weird ones? Like 2025, 494,209, or 24502,500. These are a rare type of Capricorn number. In all these cases, the pattern is driven by a modular relationship. For a 2 times n-digit number to work, the square root s, the sum of x plus y, must satisfy a strict condition. The product, s times s minus 1, must be divisible by 10 to the power of n minus 1. To be noted, the term 10 to the power of n minus 1 appears because splitting a 2 times n-digit number into 2 n-digit blocks is equivalent to working modulo repeating 9s, like 9, 99, 999. Here are proofs for two numbers. For 2025, x equals 20, y equals 25, s equals 45. 45 times 44 is equal to 1980. 99 divides 1980 is equal to 20, which is exactly x. For 3025, x equals 30, y equals 25, s equals 55. 55 times 54 is equal to 2970. 99 divides 2970 is equal to 30, which is exactly x. Let's see two more examples. 10 digits, take 6,049,417,284. The root is 77,778. The proof, 60,494 plus 17,284 equals exactly 77,778. 12 digits, it gets even crazier with 213,018,248,521. The root is 461,539. The proof, 213,018 plus 248,521 gives us 461,539. It is important to note that this is not a universal law of square roots. It is a rare property shared by only a handful of integers. For most numbers, like 1600, 16 plus 00 equals 16, but the squared root of 1600 is equal to 40. The hidden math is essentially a coincidence where the structure of our base 10 numbering system aligns perfectly with the properties of square numbers. Alright, it's time to wrap up. Leave a comment below, and don't forget to like, share, and subscribe for more fun math problems. See you next time, and thank you for watching.